Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. Today I'm going to look into the continuation of running fix. Last time we had seen running fix using position lines. So I'm going to change it to position circles today. Let us look at different cases of running fix using the position circles. So this is a second in series for running fix. I'll be coming with a couple of more depending on different data given to me in the questions also. The definition of running fix remains same. Position fixing tools given to you at different times is called running fix. But this time I'm going to involve position circles or ranges. The procedure will slightly be different because I'm not looking at position lines, I'm looking at position circles. So let us take a couple of examples. I'm going to use varying examples in this particular module so that I can show you what all different problems can arise, what all different ambiguities can arise, and how to eliminate those. Okay. So I'll be, each slide might have different values. Idea is to show the concept. So as far as the concept is understood, I think you'll be able to do any questions which comes. Now, just almost in the same sequence as what we did in position lines, I'm choosing two position circles and I'm not using any current or wind. So this is an example I've taken. I've chosen a single lighthouse. And let us say at 8 o'clock, this lighthouse was having a range of 3 nautical miles from me. And after 1 hour, the same lighthouse was 6 nautical miles. These are all examples taken to understand the concept. When you get a real question, you can apply it on the chart and find out also. Now, let us say CTS is given and engine speed given. And the question asks you to find 8 o'clock and 9 o'clock positions based on these two position circles. Now, please try to correlate whatever we did in the steps we did in position line. They'll be very similar. The only thing is line is a line, circle is a curved structure or figure. So there are slight differences and variations. As again, when you take any range, you are always measuring at your vessel. Let us say a radar. Radar is one of the most common tools for you to take a range of any object. So let's say I took a range from radar. So I have measured it when I'm sitting on my vessel, I have measured it. And it is always from me to the lighthouse. But when you go to the chart, as again, chart is clean, you don't know where you are. So you have only the object. So now what you will do is you will draw the circle from the object. And this circle need not be a full circle. It can be a partial circle also. If it is a partial circle, please follow the same principle of what we did in a position line. Wherever you stop the partial circle, please put a single arrow at both the ends. So I'm going to show you how to do it. So let us say this was a lighthouse. This is your first position circle of 3 nautical miles. Mark single arrow. Please put the timestamp. It is important. Otherwise, you will be confused. Now, after 1 hour, the same lighthouse, my ship found out that it was 6 nautical miles. Just before that, we know what do you mean by position circle. That means my vessel's position can be anywhere on this circle. Similarly, the second position circle, which was 6 nautical miles from the same lighthouse, which is a 9 o'clock position circle. So that means at 9 o'clock, your vessel could be anywhere here. So this is your basic concept of drawing the two position circles. After this, I have to continue with my course steered engine speed and then find out my two positions. So before I go, I want to quickly recap what we did on the PL. Please have a look. There's similarity because it's always confusing to solve a position circle problem. So Let us quickly recap what we did on PLs. So the same lighthouse, I drew both my PLs. Then I would choose a point A anywhere on the first PL. I would run the ship, get a Bravo, and I would take a parallel ruler and transfer the first PL, put it on Bravo. Wherever it intersects, the transferred PL intersects the second PL, it was my fix. Then I could run back and get my fix at 8 o'clock also. So the catch here is I could have taken alpha anywhere on the first PL. So based on this concept, I'm going to just modify or give you an alternate method because this small difference is very important for you to solve in position circles. Again, I'm repeating, I can take alpha anywhere on the first PL. So do you realize that the lighthouse itself is also on the first PL because you have drawn the first PL from the lighthouse. So I can choose the lighthouse itself as alpha. Please see here, lighthouse itself as alpha. I can still do the run. I can still follow the same steps. And I can still get my position at 9 o'clock and 8 o'clock. And they are correct. So what was difference between the previous slide and this slide? I have chosen alpha at the source of the position line. Okay, I have formed a parallelogram here. And I could have formed a parallelogram by choosing alpha anywhere on the first PL. And I consider the lighthouse also is on the same first PL because that is a source. Now, why did I show you this method? Remember, PL is a line, straight line, so not much of confusion. But when it comes to position circle, which is your range, it is a curved figure. So choosing alpha anywhere on the first PC is tricky. And I very strongly suggest, please do not try that. You may get it, but there are hundreds of ways you may not get it. So for that, the first and the best and the correct choice is choosing the source of the first PC. So to show this concept, that is the reason I've gone back onto the PL to show you and prove you that I could have done this PL problem even by choosing alpha at the lighthouse itself, which is the source of first PL. Okay, I could have, as far as PL is concerned, I could have chosen anywhere, I could have got it. But in PC, we don't try this. And I suggest you also please don't try. So let us check this method, which is the only method I will recommend to you to start a PC problem. So let us go back to our problem. This was the same problem 2 slides back. I have drawn the PCs, first and second one. I need to choose alpha. So do not choose alpha anywhere on the first PC, but choose it on the source of the first PC, which is the lighthouse. So this is alpha. Again, similar procedure. Please draw the CTS for 1 hour, let us say. Arrive at Bravo. In your PL, if you remember, I used to transfer my first PL into the Bravo, but here it is a circle. So I need to transfer the circle. So what should I do? Whatever I had drawn from alpha, now I'm going to transfer it to Bravo. That is the first position circle I'm going to transfer to Bravo. Keeping Bravo as the center, I'm going to draw the transferred PC. So this is the first transferred PC. Wherever the first transferred PC intersects, your second PC is your second fix. After this, if you want to know where were you at 8 o'clock, please just draw the CTS back and you will see you have got your 8 o'clock fix also. So this is the big difference between solving a PL and a PC. So in PC, please remember, always choose alpha at the source of the first position circle. Okay. I'm going to show you a small piece of ambiguity which you can get. You will get a lot of ambiguities as far as PC is concerned. I'm going to show you in coming slides. There'll be multiple ambiguities, and you are supposed to take it out either logically or from a clue in the question. So let us see how logically we do it. It is exactly the same question. I have made the position circles thinner so that it looks like a pencil drawing. So what happens when I finish this question with 9 o'clock fix? I want to get 8 o'clock fix, so I have to be careful here. I have transferred my CTS. When I transfer my CTS, you can see the CTS is intersecting at two places on the first PC. How do you say which one is correct? I've given you a clue with a green and a red mark. The idea behind this is the length between alpha and bravo has to match your 8 o'clock and 9 o'clock fix. So that means you can measure it and confirm. You will see that it will not match the red color circle. It's not going to match because the length of that line is too big. So it could be any duration. It could be 1 hour, 2 hour, whatever the question is. Please always do the run as far as the time duration between the first PC and the last PC, and try to measure this logical run, what you have done in 1 hour, and it will help you solve the problems. Let us quickly look into a question on a chart. I'm assuming a lighthouse here because I wanted to use the piece of chart. So I'm assuming a lighthouse here. Let us say this was my first position circle, which was 3 nautical miles. And after 1 hour, I was 6 nautical miles. I will choose alpha at the source of first PC. Please draw the CTS for 1 hour or whatever duration. Transfer the first position circle from alpha to bravo. That means exactly the first circle I'm drawing at the bravo. You can see they are intersecting at 2 points. I'm going to mark this green and I'm going to mark this red for very obvious reasons. Why? Because you can see they are very close to land and it is a shallow patch up there. So I consider if I'm doing a normal passage, I wouldn't be there. So this is the logic I am using. So once this is confirmed, I can transfer my CTS back. Again, there's a second ambiguity coming here. Which one is correct? For me to check, I need to use a length measurement of alpha and bravo. You will see only this is matching. These are the two matching. This does not match. Hence, this is not your first fix, but this is your first fix. So your vessel was traveling like this at 8 and it was at 9 here. So I hope this picture was good enough. I'll be using more examples, a couple of more examples with different data. Uh, so trying to get different ambiguities. So let us see what we can see further. Now I'm going to use two different lighthouses. If you remember in position lines, I had used two different lighthouses there also. So here also I'm going to use two different lighthouses. Let us say 8 o'clock, X-ray was measuring 3 nautical miles, and 9 o'clock Yankee was 6 nautical miles. Same course, same speed, same job of finding the two positions. I've got two different ranges at different times, so it's running fixed, but two different sources. So let us draw this. I'll be a little bit fast. I'll not be writing all the steps because it is a repetition. Already we have been doing a couple of repetitions. So I call this first lighthouse X-ray, Yankee, second one. So let us say 8 o'clock, this was 3 nautical miles, but 9 o'clock Yankee was 6 nautical miles. I will start the question again. I'm going to use the source of first PC always as alpha, run it for 1 hour. At Bravo, please transfer the first PC again. Wherever it intersects the second PC is your 9 o'clock fix. Put your CTS and you will find your 8 o'clock fix. So this was one more method using two different lighthouses. Let us see here. I have changed the example. It does not exactly match with the previous slide. I've changed it just to suit my explanations also. Let us assume this as the first lighthouse X-ray, and I'm assuming Bill of Portland as the second lighthouse. So my first lighthouse PC was 3 nautical miles, and I'm going to repeat as if the second lighthouse was also 3 nautical miles at 9 o'clock or 1 hour. I can take any example because this is possible. I can have first lighthouse 3 miles, and after 1 hour, the second lighthouse was 3 miles. It's okay. So let us start this. I'm using alpha as the first source. Run the vessel for 1 hour. Transfer it. You can see it is intersecting at 2 points. Now I need to resolve the ambiguity. I'm marking this already as red, obviously, because you can see a lot of shallow patches are there, and I'm hoping that if I'm doing a normal passage, I won't be there. So that is the logic I'm using. So obviously, if I take the same length here, this is also wrong. Why? Because since I consider that final position, I cannot be at the shallow patch, because otherwise by now I would have got a lot of alarms, but I did not get. So that is what I consider. So what is the second choice for you? Second choice is this. Now you can see the same length. If I put it, it matches here. So this is more logical for me in this question, where I'm using the second intersection, not the first intersection. So we have resolved a couple of ambiguities already. You might find more. I'm going to solve the same question. Right now, this was only a check. So I'm going to complete this question. You can see there's one more ambiguity. So I don't consider this position also because the length is too small between that 1 hour. So let me complete this question. I consider this as my correct position. This wrong. And this I just discarded. So I transfer my CTS here. This is your 8 o'clock. And the vessel was like this and like this. The last one. This looks more logical. You're not anywhere on the danger spots, and I can still travel. Okay. Now, again, I'm just like the PLs, I'm introducing the first environment, which is your current. So let us look at the current. I'm introducing 135 and 2 knots. Earlier process, everything is similar. So I'm choosing alpha at the lighthouse or the first source, drawing alpha and bravo based on the time duration, and here it is 1 hour. Remember, from bravo, I need to apply my current now for 1 hour. So it's going to form a 1 hour triangle. So I've finished my 1 hour triangle. This triangle is correct, but the position of the triangle is wrong. I need to find out where I should put exactly. Now, till now, I was transferring my PC to Bravo, but since I have current now, I'll be transferring the PC to Charlie. So when I transfer my first PC to Charlie, this is what I get. I get my 9 o'clock fix. The moment current is involved, CMG is involved, fix is always on the CMG track. So please transfer only the CMG, no more CTS. Okay. So this gives you your 8 o'clock fix. Now, let us try the same method on the chart. Let us see here. I would have chosen again different values. Don't bother about it. I would have chosen different values. It's okay. Any values, whatever is possible. For me, I need to show you on the chart with clarification regarding ambiguity. So I have chosen my values. So that is how a question is created. So I've created my own question. I'm going to take Bill of Portland for this question. I consider first PC 8 o'clock, whatever miles, 3 miles. Let us say second PC is 9 o'clock. Let us say 6 miles. I'm assuming today or on this question, I was traveling 090. So I've chosen the first PC, source of first PC as alpha 090. Let us say 12 nautical miles, arrive at Bravo. After this, I had a current. So let us say 1352 knots. So current, I'm on Charlie. I can finish the triangle. I've got the CMG assembly. This triangle is correct for 1 hour, but the positions are wrong. So for me, I need to transfer my first PC to Charlie. The moment I do it, I have again ambiguity. Two intersections are there. So let us say if I transferred my CMG here, I would have got this. If I transferred my CMG here, I would have got this. How do you say which one is right? Let us see which one is wrong. If you see on the top, this is wrong. Why? Because the whole line is passing over land. So that means this position is wrong for me. I'm going to discard it. So this is correct right now in this question. 9 o'clock fix. Then I need to check the length. So length is going to match only with this one and is not going to match with this one. So I've given you various examples with different data. I gave you different scenarios. I hope it was clear. So the vessel was traveling 090. Vessel heading is still the same. You would have seen it coming at 9 o'clock on this position. So that was a small presentation involving your position circle rather than position lines. I have chosen a few cases as we saw initially with no current, no wind, with a single lighthouse, then multiple lighthouses. And then finally, I chose adding the current also forming a chart triangle with using your allowing method. I'll be making a couple of modules on running fix. My next one would be a single module where I will involve both position line as well as position circle. This time I'm going to add leeway also because questions can come with leeway as well. So I'll be forming again a triangle and making a video with leeway. So till then, keep watching Jal Prayag. And I'll catch you soon with the next video. Vanakkam, namaste, namaskar.